Good morning, SQL community. My name is Jeff Garbus, and I'm going to be presenting today's webinar, Case Studies in Rewriting Transact SQL Code. Normally the introductions are held by Ray Renala, who's out this morning, so I'm going to introduce myself. It'll be a little bit less classy, but we'll have a little fun doing it. Hopefully many of you have seen previous presentations and know who we are and what we do, but nonetheless I am going to give you the quick 30-second on Soaring Eagle. We are database experts. We do everything from managing systems down to heavy performance problems. If you need assistance, give us a buzz. We do consulting. We have our own suite of training courses. Our largest growing segment right now is our managed services division. If you are an overworked DBA and need a little relief and want your evenings and weekends back, give us a buzz. If you can't afford to hire another full-time DBA and need some assistance, give us a buzz. We are here to help. That said, I'm going to pretty much dive into the webinar, and hope you're all having fun. Questions I will handle at the end of the section, so if you have questions, go ahead and put something in the questions box, and we will get to those toward the tail end of things. Now, as we're looking at the heading here, why other people's code stinks, we can almost also write, why my code stinks. I don't know how many of you have shared a similar experience, but I know that when I take a look at my own code that I've written a while ago, I tend to look at it and ask myself, what was I thinking? The reason for that is often that your head is in a particular place when you're trying to perform a particular type of activity. So things like documenting your own code so that you can remember what it was you're doing tends to be pretty critical. But when we start looking at why other people's code stinks, what is it that actually creates the odor? Well, as we're looking at this, most of the time when somebody gives you a chunk of code and says, here, rewrite it, the problem is poor performance. It's not running fast enough. It is not doing things as well as it's supposed to be doing. It's causing blocking. It's using up too many resources. It's performing table scans of your 300 gigabyte tables. But in general, that poor performance is what you tend to look at. So a lot of the things that we're going to be talking about today in terms of rewrite are going to be performance related. We'll talk about what caused the performance to be bad and what we did to fix it. The next is poor documentation. I know that I've written things that I've looked at a week later and asked what in the world was in on my mind when I wrote it. Usually I consider myself to be pretty bright, but when I'm doing a code review of my own code, I sometimes second-guess myself. Always document what's going at the top of your code. Use stored procedures. I know that there's a lot out on the internet right now that is suggesting that straight SQL is almost as efficient as stored procedures. I have to take exception to that from a variety of reasons. A couple of quick ones. If you're sending the name of a stored procedure and saying execute the stored procedure from your client to your server, you're passing over a few characters across the network. If you're passing across 20,000 lines of code that could be in the stored procedure, you create additional network bottlenecks. That all by itself is probably enough reason. Modularity is a good reason, and I'll just simply stop there. I could do that for 10 minutes. Next is inadherence to standards. In the past, I have not done a lot of great things with standards. Why? SQL is free format. You can write whatever you want. Every single client site I've got has a thick standards manual. Nobody adheres to it. As you start going through these things, your eyes get used to what you're looking for and you find it. Now that was true up until about 5 or 6 years ago. I was at a client site where every piece of code that I looked at, every single stored procedure was coded in such a rigid manner that making modifications to the code was almost trivial. Since then, I have been a fan of consistent formatting of code and other standards which comply with the whatever ISO compliance you're looking to get to, because having comments at the top of the code, what this stored procedure is supposed to do, what it's called for, why it was written, what it interacts with, what systems it works, change history, all is pretty critical to being able to maintain code. An interesting informational nugget. The cost of maintaining code over the lifetime of an application is about 7 times the cost of developing it. So $1 million to develop it, $7 million to maintain it over the lifetime. Those are Gartner Group and CIO Council numbers. I do not make those up off the top of my head. I could, but it's not as fun when I can quote something and have somebody look it up and say, oh, yeah, I didn't believe you, but that was right. So these are the reasons that we tend to get into people's code. Let's talk about some specific examples. One of my favorite pieces of code to make fun of occurred several years ago, over 10 years ago now. It was a piece of Transact SQL code, and what had happened was we had been brought into an organization purely to make everything run faster. It was an organization that had gone from a couple of gigabytes of data to a couple hundred gigabytes of data, and 10 years ago that was a lot of data. Today they're up in the multi-terabyte range with the code fixes that we put in. But we were in there fixing things that worked great with 10 or 20 or 50 or 100,000 lines of code, no longer working well with 10 or 20 or 50 or 100 million lines of code. So we spent a lot of time in there fixing code, adding indexes, training developers, showing them what they should and shouldn't be doing. By the way, this material that we're looking at today is the tail end of a 5-day class that we do where we teach people the right and wrong ways to write Transact SQL code. So back to this particular example, the head developer said, hey Jeff, we've got this chunk of code and it's running okay. It's running in about a 4-hour window. The catch is we only have a 6-hour window, and 5 years ago it only took 20 minutes to run. I'm a little bit worried that in the next year, 18 months, we're going to blow through the window that we've got to run the code. So I said, okay, I'll take a look at it. And as I took a look at it, this is what it did. It took every row from an 80 million row table and put it into tempdb, into a temp table. Then it scanned the table, deleting a large number of rows. Then it scanned the table, deleting a large number of rows again. It repeated that until it was down to just a couple hundred rows. And when it was down to just a couple hundred rows, it returned the couple hundred rows of data. Now, let's talk about why that's bad. First of all, they're crushing tempdb. Second, they're scanning the original 80 million row table. Secondly, every time we're doing the update or delete to that temp table, the entire table is getting updated. All the deletes are getting logged, so we're crushing the tempdb log as well as the tempdb data over and over and over again for a period of several hours. Now, we do tend to decide to treat tempdb as a bottleneck, but if you're going to treat tempdb as a bottleneck, try to avoid putting things in tempdb. So the developer came over, I sent him an email, I said I'm ready, he came over, I explained to him what was going on. I don't think he'd even looked at the code, he was a very bright guy. And I said, this is what you want to do. Scrap this code and just bring out the few hundred rows of data that you need with the where clause. And he said, yep, that makes perfect sense. I wish I'd taken the time to look at this before I brought it over to you. Well, that was interesting, but as he walked away, he turned around and said, hey, Jeff. And I said, yes. He said, do you think we should fix the other 40 or 50 batches that do exactly the same thing? I said, yes. That made all of their batch stuff run a lot faster, and within a week or two, their multi-hour batch window was down to minutes. Big hero points for that one. Now, that was my favorite disaster code story until about 2 years later. I walked into another shop, and this other shop was a situation. I met these folks after speaking to a local user group meeting, and they called me up and they said, hey, Jeff, the things you taught us at that user group meeting were great. We made a lot of our stuff 6 times faster, but what I'd like to do is have you look at something. It's running in 15 or 20 minutes, it's timing out. Now, we brought a consultant in to develop this, so we're pretty sure the code is good. We're just not sure why it's taking so long to time out, or why it's timing out. On our smaller databases, it works fine. So we went in and take a look at this, and I took a look at the code, and I asked the question, what are we doing here? And this is what the code was doing. This was a demo, and I suspect that most of the people on this webinar have similar types of application, although I doubt you're handling it the same way. This was a pick screen for a multi-option demographics research type of application. So we want to send out a coupon to everybody who is between the ages of 60 and 80 years, has more than 2 cats, less than 4 dogs, has an income in a certain range, doesn't own their own house, does have a vacation home, and fits a variety of other criteria. There are about 80 separate criteria that they could use for their marketing. All right, so we've got the marketing stuff down, but how do we handle the query? Well, it was a multi-table join, and so what they were doing was as follows. They took their basic customer list, and they took the entire customer list, and they put the IDs for the customer list into temp table 1. Then they wrote a query that said, insert into temp table 2 all the rows from temp table 1 where the ID matches the criteria. So if there was no selection for the right criteria, all the rows went over. So if they didn't do it based on, for example, hair color, the whole 600,000 rows got moved from temp table 1 to temp table 2. The next thing they did was to delete all the rows in temp table 1. That's delete, not truncate. Then they moved all the rows from temp table 2 back into temp table 1. Then they deleted, not truncated, every row in temp table number 2. And they repeated this entire process 80 times. Now, we've already talked about why that's a bad thing to do to tempdb. Let's talk about emptying a table with a delete rather than a truncate. Truncate just deallocates the pages. A delete logs all the pages that you're deleting. So if you're just emptying a table, to do the delete is really a waste of time and resources and takes many, many, many times longer. Not only that, it's going to help crush your log. So any of you who've got a lot of log wait time, that's not going to help it any. To do that 80 times is absolutely crazy. I performed the math on this, and they were performing a few trillion I/O requests for each of these demographics research for a relatively small table. It was only about 600,000 entries in their customer list. Plus, they were repeatedly joining to the same tables over and over and over and over again, not to mention all the damage they were causing right there in tempdb. My recommended solution, construct a query. And by the way, that became a chapter in this class subsequently. Construct a query. Just write a select, bring the columns back that you want from, list the tables that you care about, that you're actually bringing information back with the join clauses, construct the where clause, then execute the whole query. They said, well, the consultant who did this we paid a lot of money to, and I said, ask for your money back. He did a very, very bad thing, and this is why. They said, well, can you rewrite this? I said, yeah, or you can do it. And they said, well, will you do it for us? We'd like you to do it. It took about 2 days. I think the other consultant spent about a month writing it the other way. But in about 2 days, we had this. It was constructing it and running great, and everything was running in a few seconds. Those few that weren't, we made a few index adjustments, and it was done.